right, welcome back to section 2, where we were talking about variables and printing to the screen and capturing data from the screen. So we're going to try it out. For this video, we're going to be using Replit. In the future, we will move to Visual Studio, but for now, we're just going to use Replit. So I have started a new program, and I have added a header with the multi-line comment. You can see lines 1 and line 5 show an example of a multi-line comment. When you're creating programs, you should always have a header information in it, including your name and then a description of the program. The name of the program is not a description. You need to have a casual description of the program itself. And then line 6 and 7, I have included the IO stream. Line 7, I've included the IO stream, and that is where I can find CN and COut. And line 8 is using namespace std. That's so that I don't have to put std in front of every CN and every COut that I do. Instead, if I'm using a standard namespace, I can avoid that. So I'm also going to put a pound include string because I know that Replit doesn't need it, but depending upon the platform that you're using to create this, you might actually need string, because what we're going to be doing on line 4 is we're going to prompt the user for a name and a radius of a circle, and then we are going to calculate and display the diameter and the area of the circle. So I'm going to start the program by creating some pseudocode, mapping out a plan of what I want to do. So we're going to declare some variables first. Then we are going to prompt for the name and the radius. And then we are going to calculate the diameter. And if you have to go online and find out what the equation is to calculate a diameter, we're going to see that it is the radius squared. And then once we have done that, we are going to calculate the area. And again, I'm going to do my handy dandy Google search to find out that the area is pi r squared. So that would be the radius squared times pi, and the radius squared is the diameter, right? The diameter multiplied by pi. So I'm going to put pi in here. No funny comments about my pi. There you go. And then we're going to display it. All right, very good. So this is how I want you to write your programs. I want you to come up with some pseudocode, and then I want you to circle back around, and we're going to add a little bit of detail. The detail that I'm going to add now is the variables that I might want to include. Everything inside of main, I'm going to tab in for readability's sake. And so it seems to me that for this one, I'm going to need a name variable. And then it seems like I'm going to need a radius. I'm going to need a diameter. And I am going to need an area. And since we're going to have to multiply it by pi, I'm going to need the value of pi. All right. So the next thing when I'm circling back around to add a little bit more detail is how do I want the results to look? So what I would really like to say is something like George. The diameter is 15.25 and the area is 9. And now I'm just making up numbers, but this is kind of what I would like it to read. And I got to spell that right. So I'm going to mirror back the diameter and the area. And if I'm going to mirror back all relevant information, and the radius is 2. So once again, the values that are in there don't matter. These are values that don't add up, but this is just placeholders. This is what I would like it to look like. So the next thing that we're going to do, now that we have mapped out a plan or written pseudocode, then we're going to come in and start filling in our pseudocode. All right, so I'm going to create a string. I'll call it name. I'm going to create a radius. These three will all be, we'll make them floats. How does that sound? So I'm going to make a radius, a diameter, and an area. I'm going to declare all three of these on the exact same line. and then pi. So I'm going to make this one a floating point as well. I'll call it pi. I'm going to initialize it to 3.14159, and then I will put a float after it with my semicolon, indicating that this is, we'll make it a floating point number. All right, so let's see if we can prompt for the name of the radius. So on line 15, we are able to cascade the declaration of variables, and on line 19, we are going to cascade the prompt for, or I should say the read for multiple variables. So I'm going to start with our cout, and I'll say something like, good morning. Oh. Enter your name and the radius of a circle. I'll even put a little space after the question so that my cursor doesn't blink right up next to circle, and then let's read them in. I'm going to read them in with cin and the stream extraction operator. The first one that I'm going to read in is name. The second one that I'm going to read in is radius. Now notice that they are not comma separated or anything. In C++, every executable line of code ends with a semicolon. And then I'm going to calculate the diameter. So I'm going to see that the diameter is going to equal the radius multiplied by radius. Not too, pretty straightforward, right? Oops, as long as I'm spelling it right. And then we're going to calculate the area. So if the area is equal pi r squared or r squared, that is going to be the diameter multiplied by pi. And then we're going to display the results. So I'm going to build this print statement that I've already decided that I want. And so we're going to cout. And the first one is going to be the name. And the second one, it looks like, as I'm building this print statement, that I need a space, and I need the diameter is space. So I'm actually going to copy that, and I'm going to put it inside of here. And then it looks like the next thing that I'm going to have, that is the diameter. So I'm going to put the variable there. The next one is going to be space. Oops, not the 5. Space, and the area is space. So I'm going to copy that, and I'm going to put it in double quotes because strings go in double quotes. The next one is the variable. I'm pretty sure that that represents area. And then comma, and the radius is all the way up to Control C. We will paste that. Oh, wait a minute. We wanted to paste it into some double quotes. And then it looks like the last one is going to be radius. I am actually going to add an end line here, and then I'm going to end the whole entire thing with an end line. Let me move it so I can see. All right, so I can see the entire print statement here. I'm just going to run it and see what happens. So it's going to ask me for my name and a radius. So I'm just going to type in my name. Whoops. And then I'm going to press enter, and now it's waiting for the radius. So I'm going to put in 2. Well, I'm pretty sure 2 squared is 4, and I'm pretty sure that 4 times 3.1 is close to 12. So it looks like I have the correct answer, a diameter of 4 and an area. I kind of approximated the area. So let's try it again. I'll run it again. This time I am going to put my name, and then I'm going to put a space, and now I'm going to put a different radius like 3. Pretty sure that 3 squared is 9, and then 9 times 3.1, 9 times 3 is something around 27, and so I'm getting an approximation of 28 from the mirroring back the radius of 3. I'm going to run it one more time, and this time I can put in some kind of floating point number because it is a floating point after all. And I'm assuming because I put in 2 successful runs of the program when I had an idea of what the output should be based upon my test input, I had a good idea of what my output should be. And since it worked at least successfully twice, Now I can put in some other arbitrary value, and I can see that it is giving me a value. So when I write this program, you probably already know, hopefully already know, that pi, this is not how you spell pi. Pi actually should be a constant. So let's actually create it as a constant. I'm going to use the keyword const, or const. I'm going to make it a float, and constants would typically be written in uppercase. And now I'm going to set it equal to 3.14159. And then I'm going to calculate the area again. So this would say radius multiplied by radius multiplied by my constant pi. And then I'm going to output something like area is still area. And then we'll do an end line at the end of it. And at the end of the program, depending upon the platform that you are using, I'm going to put a return 0 because when I look at main, this is saying that main was an integer value, which means that main is expecting the return of an integer. And depending upon the platform that you're using, you may need that return 0 there. So I'm just going to include it at the end, and I'm going to run it one more time, or run it again, and we're going to see if it gives me the same answer. I'm going to drag this over a little bit so I can see a little bit more of it. Enter my name, and then the diameter of the circle. So I'm going to put it in there, and it says that the diameter is 47,882. There is 47,882, and so it looks like it's calculating exactly the same again. Let's try it again. We'll try Sammy with a space. We'll put some large numbers in there. And now I see that it's giving me scientific notation because the numbers are becoming very, very large in scientific notation. And so one of the things that we can do is I'm going to set my precision to 3 floating point numbers. First of all, I want it to display as a floating point number. So in order to get it to do that, I'm going to use the stream insertion operator with fixed. And then I'm also going to, because it's fixed and I had a whole bunch of floating point decimal places there, I am going to force it into 3 decimal places. So I'm going to see cout.precision. Precision, and inside of here I will put a 3. See if we can force it to 3 decimal places. Let me run it one more time. We'll use a large number. There we go. So now I have actually forced it to 3 decimal places. But if you'll notice, when I used fixed here, the other 2 are still in scientific notation, which means that I might need to come up here and make these original 2 fixed for both the diameter and the area. I'm going to make both of those fixed, so it's not going to default them to scientific notation if they are larger than a certain size. We'll do it again. George. There we go. So now I have the diameter and the area are hard-coded to 3 decimal places of precision. I see those 3 decimal places of precision right here. I see that my radius, because this was my print statement from above, this one is showing the default 6 decimal places, but this print statement, the very last print statement, is showing with only 3 decimal places because I forced it into 3 decimal places. Since we had a chance to try it out, next it is your turn. What I'd like you to do is I'd like you to write a program to calculate cars. So the price of a car is the base price, any price for options, the sales tax, the licensing fee, all of those together. And I want you to display that total with other relevant information It's never a good idea to slam a number onto the screen. And at this point, saying total and giving the car total is not going to be enough. I want you to mirror back all relevant information. That includes the car's base price, the options price, the sales tax, and the licensing fee. I want you to mirror back all 4 of those, as well as the total of the car. I want you to start with a pseudocode, so I want you to write up some pseudocode, and then include test cases for the program. You can put them in a spreadsheet or a table format. Refer back to the Getting Started module for my expectations of test cases. Tell me what to key in for each of the 4 input fields, and then tell me what the outcome is if I key in all 4 of those values. There should be multiple successful runs of the program. One successful run is not a comprehensive set of test cases. Once is just sheer coincidence. Twice is a fluke. 3 times is kind of proof that your program is running successfully. So I want you to start with at least 3 successful runs of the program, and then I always want you to include invalid input. So what happens if you put invalid values into each one of these 4 numeric input fields? So I want you to include test cases for invalid values into each one of those 4.